the second time I've spoken about security. That is the second time I've spoken at OWASP. I was here in the fall, and I spoke about Spectre and Meltdown, which is sort of at the other end of the technology space. I don't know. So, is 1% a big number? Is 1% a big number?
It's complicated.
It's complicated, right. Is it a big number when it comes to an interest rate at a bank? Is it a big savings when looking for a sale on a loaf of bread? Is it big when it comes to vulnerabilities in a commonly used repository of open source software?
Exploitable vulnerabilities?
All right, about me. So, I'm working in embedded operating systems right now, but many people, I'm always interested in other opportunities. One of the things is I am paid to worry. It's part of my job, but I do it naturally, I come by that naturally. And I'm also not a Python developer, so I'm going to talk a lot about Python stuff today. But I don't have the same Python background that people like Kathy or other people here will have. Here's what I'm going to show you, though. So there's a lot of security risks in a supply chain. And often we don't recognize that that is actually an attack surface in your software development process. I'm going to use Python's package repo, the main one called Pyup. And I'm going to look specifically at one package called Pycrypto. Does anyone here use Pip? Yeah. Very easy, isn't it? Does anybody know Pycrypto?
Sorry, my mornings.
You got it. Good, Kathy. We're going to talk about that more. Okay, so look specifically at Pycrypto as an example. And I'm going to go look at comparisons with other repositories for other languages, like npm as an example. And also I'm going to go through and give you a checklist of things to look for when you too are thinking about how to handle dealing with security problems in third-party repositories. So the DevSecOps problem, and I'm not a DevSecOps expert like other people, but to some extent, you want to enable people to be responsible for security or be able to manage things on their own. More people are getting, and part of it is getting more people, having more people be aware of it. And I think it needs to be recognized in development groups that there really is an attack surface. So here's the security nihilist's view, right? So bad guy who always has to wear a mask and have a hoodie, right? Stereotypical hacker, he goes and contributes some malware that plants a backdoor in some open source software, some sort of project. It gets picked up by a repo, right? And then application developers will be using that package in many applications, and after that, somehow the hacker profits, right? That is sort of the highly concerning path that people worry about professionally, right? And if there's no proper controls, essentially the hacker can plant something at the very beginning, and it may take a while to perpetuate to get to the other end, but if done successfully, the backdoor can be planted in many different applications. So is this true? Is it just me as a professional warrior? Has this ever happened?
URL lib?
URL lib, that would be one. That's an example, but there's actually quite a few examples. I did not look far. I did not have to look far. I put this together for this deck. Dockerhub, so there was containers that had backdoors in them. npm, some various typo squatting ones. Typo squatting is interesting. There's always a lot of, these repos have a lot of process involved in ensuring people don't typo squat for package names, right? Some stuff with get cookies. npm also had one which had to do with left pad. It was an intentional hack. It was a function that dropped and ruined lots of people's stability in their websites. But Python's Pip and Pypas had a few of them. So some of it is typo squatting, and other ones are SSH decorate had a problem also. But there's more because, of course, we know about some of them. Some of them have been publicized. There's been other ones that have been hacked and we just didn't hear about it. But also, there could be a lot of stuff hacked that just hasn't been discovered yet, right? And so Although it's good to focus on the 1% that we know have problems, maybe we should also be concerned about the process that we follow that has led us to this situation where we have these problems. So checking for known vulnerabilities. Kathy did a great job of explaining various tools that can be used. I encourage you to do static analysis. Often static analysis is focused on developing new code, newly developed code, and less on the stuff that gets pulled in by it. So I would suggest you don't just run static analysis tools on your code, but also the code that your code uses. Dependency checkers are a good extension to help mitigate against this. Rule sets are constantly changing, so just because you run a scanner once doesn't mean that you can fire and forget. It's good to update the rules that are being used and rerun them against the same code later. So so this is the backend to Pyp. Pyp is awesome. I love it. Actually, there's so many of these tools that are just make it so easy. If you want to install the OpenCV framework, you can do it in 3 lines if you ignore the dash user, which you should really be using. Incredibly complicated things can be done in just 1 line. You can see that with Docker also and things like that. But the problem is that makes it so easy that people, which is intended to mask the complexity, that people then forget that there is a complexity behind it. And this is an area of concern. So what could possibly go wrong with this? Okay, so the people here in this room, you're stickering because, of course, you know, and the reason you know is because you're the kind of person that comes to this kind of meetup, right? But we probably work with people who may not have that same experience and maybe have other things that they want to do on a Thursday evening. So not everybody knows that this has some dangers. So what I thought I'd do is, I sort of theorized that this was a problem, and I wasn't really sure, and I thought, well, let's go see if we can find some numbers. So what I thought I would do is I would go through the Pypi online repo and just scan for known vulnerabilities and what was in there. So, yes, my code is open source. However, I'm the only one who's ever written it. Who's ever run it, so congratulations. Okay, so here's what I thought I would do. I thought I'd go through the most downloaded packages on Python. So the way that Pyp works is you go say, hey, I want to install this package, and it downloads that package, and it looks at its requirements file. And its requirements, it says, oh, I have these other packages I have to pull down. So it goes through and pulls those down, etc., and it recurses. But the only deterministic way to actually to figure out what is actually going to be downloaded is to actually install each one individually. Okay. So first of all, there's a Pypi stats. It tells you all the most commonly downloaded packages. So I took the top 5,000. For each one of those, I went through and run a container that does the install, figure out what actually gets installed, take that list, and then I run it against safety, which is from a company called Pyup, verify against known vulnerabilities. Kathy mentioned that too. After that, I generate a report, and the report spits out a Google spreadsheet that shows me all the numbers. And the numbers are in the form of column. Says, here's the package that got installed, here's where it ended up pulling in, here's the Pypi ID, and then a description of the vulnerability. The backend for that, the sort of mechanics to that, are all done by the safety program. The program called safety. It's an unusual, unfortunate word for that kind of tool. But anyway, I ended up with this spreadsheet of problems. So, and safety, by the way, is an excellent, attractively priced program. You should be running it. You just run it against the package that you want, or your requirements.txt file, goes through and finds all the problems. I think their database is updated quarterly, but if you pay the money, it can be, you get much more, it's updated much more frequently. So here are the packages that I found. I'm not going to list them. I'm not going to go through them all, but essentially there's some directly vulnerable ones that were in the top 5,000. And then they also pulled in other ones that were also on the list. So 5,000 is a large number, right? And this is about 1% of 5,000. But the concerning thing was just how commonly some of them were pulled in. So the findings here, All right, two commonly used versions of Python are 2.7 and 3.x, where x might be 3.6, 3.5. So of the 57 most commonly downloaded ones, a bunch of them I couldn't get to build. I think those are those are the numbers for 3.6. 2.7 is similar. A bunch of them didn't compile. I found 1% that had problems. But now I want to talk about Pycrypto. Pycrypto is the 240th most downloaded package from Pypi. And it has had no vulnerabilities, and it's had no vulnerabilities for going on half a decade. It has at least 3 known vulnerabilities, at least 3 known to me. And you can see based on the numbers that some of them go back quite a ways in time. It had 1.6 million downloads in February. It's required by 9 packages of the top 5,000. And if you go further down, it's probably included by many more. The maintainer appears to be vital signs absent. I've contacted him and heard nothing. And last updated 6 years ago, 5 years ago. So this is a problem. Should you be including Pycrypto in your software? Probably not. How many people are using Pycrypto? I don't know it. No one's going to raise a hand. I know what project it is. We'll talk about it now. Okay, so Pycrypto. So I looked at that and thought, this is not a train wreck that I can just pass over. I have to do something. I feel professionally compelled to actually take care of this problem. I cannot, witness these crimes of security and just not do anything. Okay, so I had some choices. I thought, okay, well, I can go and fix Pycrypto. And I'm not a cryptographer. I don't need another hobby in my life. Right? This is not for me. I can go and fix all the packages that use Pycrypto. And at first I thought, hey, this is a really good idea. And I thought, okay, I'll just start with 5. And I filed 5 defects, 1 for each of them. I think 2 of them just got dropped. 2 more I've never heard back from. One said they would in a future release, and 1 package actually fixed it. So the 57 used to be 58 or something. But it's an infinite amount of work because you can't constantly be polling every single Python project in the world looking for somebody who's Pycrypto. What you need to do is you need to enable other people so that they know not to use Pycrypto. A good way to do that is to force breakage. People will fix things when it breaks. So just removing Pycrypto altogether from Pypi. What that would do is that anyone who goes and installs a package, you would try and search for Pycrypto. Pycrypto wouldn't be there, and so the main thing they were trying to install would break. I'm somebody who worries, I'm a security professional, I worry about things. To me, it breaking so that it doesn't run vulnerable code, fail safe, I'm good with that. But the rest of the world would not be safe with all their projects getting killed. So anyway, I thought, okay, well, I will see what I can do. I'll go contact the people responsible for Pypi and see what they can do. So I went and talked to them. Remember, I'm not a Python programmer. This is all the background on that. I said, so how do I get a vulnerable package removed from Python? And they said, it's up to the package maintainers to make sure they deal with the vulnerabilities. That guy's, essentially dead to us, right? Hasn't been heard from. Or get the users to do their best to not use the package. But there's no way to control that, right? I don't know how you can instruct the world to not do what they are already doing. Like, this is just not feasible. So then I thought, okay, well, what more can I do about this? So other avenues I have was, I thought maybe I will follow in the official mechanisms and processes to actually inherit Pycrypto. Because on Pypi, if there's an abandoned package, they want somebody to maintain it. So I thought, maybe I will step in and just become the Pycrypto package maintainer. Then maybe I would, the next thing is I would put a notice in. You would update it to 6.2 and put in a notice saying, this is a really big mistake, you shouldn't be using this. And then, even me, I thought maybe I'll just remove it from the repository altogether. If you inherit a package, you can actually delete it. So I had thought about doing this with Pycrypto. It seems weird to think that this is, where fate has brought me to, especially for somebody who's not a Python programmer. So what is the real problem? And this you'll see in many aspects of security, information security, I think. You've got this balance, right? And it's secure and it's ease of use. And I think many people, who take their Thursday evenings to spend it with people like me, you are concerned that the balance is too far to the right. So this also comes into play too when it comes to managing online repositories for packages. So if you look at the way Pypi's and Pyp, what they're optimized for, they're optimized to make sure it's easy for people to push their code somewhere in a standard way that's easy for other people to install it. It is not their role and not their objective to maintain or make any assurances as to the security or stability of the packages that are posted, right? They're just trying to make it easy for people. That, and that is a conscious choice that they've made. And, if you approach them and say, hey, why don't you think about doing it this way? They're just not set up for that in terms of, money. So they too have very much chosen the easy to use route. Okay, so what should you be concerned about? The upstream repo checklist. If you are using a third-party repo, I think you might consider looking at these things. So is there a clear governance statement? Right? Has somebody actually taken the time and put up a page called security or something and explained what they do, right? And if they care. You shouldn't have to email someone to be able to get an answer to that. That includes not just online open source repos, but probably your third-party vendors also. The next one is, do they have an incident response process that is defined and that they have, that they have actually followed? Submission control. Do they actually have any form of identification check of the people who are submitting code to the repo? In the case of Pypi, you can be anybody. You can make up an email address. But I'm not even sure. I can't remember if they actually even validate the email address. But those are free anyway. And are the packages signed? So when you actually download the package, do you know that you're really getting the package you thought you were getting? Maybe it actually did the search check to make sure that the certificate matched or came through an HTTPS connection. You have some sort of reliability that you actually were talking to who you thought you were talking to. But then is it signed by the actual user that can be verified? Often people will download something through Pyp, it'll sit in their cache. There's an temporal exposure for somebody to tamper what's in the cache. The signature there is no signature to ever check. So what I have. The package is manually reviewed before acceptance. Wouldn't this be great if there was somebody and they looked at all the incoming packages and then they ran Bandit or whatever tool that they need to Coverity, looked for all the problems with it and said yes or no, we will allow this or not. I would say that should be on your checklist. If you're looking at a commercial provider, I would expect that would get a yes. Integrity checking. So are package signatures mandatory, right? Are you able to upload a package that has not been signed? So Dockerhub. What's Dockerhub like? Do people use Docker? Docker's awesome. What's the situation with Docker and package signing?
Doesn't.
What's that?
Doesn't.
It does.
You have to create a website.
That's right. It does, but it doesn't have to, and it's off by default. And if it's signed, it isn't even verified by default. So maybe not Docker. I don't know if they've made this claim, but others, other companies that I have talked to have made the claim of yes, we support package signing, but it turns out you can just ignore it anyway. So I'm not sure that it really qualifies. The other thing is having tools to verify the integrity of the packages you've already installed. Because maybe you have something on disk, you're already using it, something tampers what you have on disk, can you actually verify that it's identical to what you've got? Right. So actually, I have a love-hate relationship with RPM on Linux, but my love part of it is that it can do an RPM-V, and will go through and check the integrity of every package that's been signed and verifies that it is what I thought I would install. Monitoring. The other thing is, are you able to monitor and get notification if something has been tampered in your list? So I did a quick comparison of different online repos. I looked at Pypi, I looked at NPM. I have a strong dislike for PHP, but I looked at Packages. And I also looked at Dockerhub, the sort of unpaid implementation of it, not the enterprise-based one. And then I looked at this kind of group of Red Hat, Microsoft, Apple, Ubuntu would be there, and a kind of commercial OS vendor. So all the commercial OS vendors had a security governance statement that was available online. It was pretty clear to understand what they would actually do. They also all had an incident response process, right? Even like Slackware, other, I'd say, less established operating system vendors have those sorts of things. Submission control. So in the case of Red Hat, Microsoft, and Apple OS, commercial OS vendors, their deal is that they select the content that you get. Okay. You might actually consider, if you're using the OpenCV package for Python, you might actually consider getting it from your OS vendor and not directly from pip. That's another way to do it. That way, there is at least some intermediary in there who hopefully will have done some verification. It would also will notify you if there are vulnerabilities. They actually vet all their packages. They sign all their packages with their key, and they publish that key. You can also verify if what you have on disk has been tampered. I don't know how to do that in Windows because I don't know anything about Windows. But free monitoring, you can subscribe to mailing lists and get notifications. And there's also commercial monitoring for these. So here's, Pypi gets a lot of no's. It does get the free monitoring, give it a check mark there because you can actually get Pyup's commercial support for free monitoring or safety, which the tool I described is free, and you can get commercial also. NPM did much better than I thought, actually. NPM is much more robust than I had thought. I mean, one indication of that is that issues that have come through, you can see that they have responded very well in terms of how they've dealt with the issues. They are clear on their security governance statement. They do have an incident response process, and we know that it works. They do some form of submission control. I was thinking about putting an asterisk in there. They don't manually vet packages. So if you can prove who you say you are, you can still upload malware there, right? But at least then you have known hackers. And anyway, proving who you say you are on the internet, what is it? Nobody knows you're a dog. So I said yes for integrity checking, but I'm not sure that signing is required now. PHP packages, it comes from a different time, right? And that was very much at the time of not being nearly as suspicious of other software developers. So it gets a lot of no's. Is anyone here old enough to have used Perl's CPAN? No. Yeah, people have CPAN here as well. It gets a lot of no's. Actually, it has no free monitoring or commercial monitoring support. One of the tricks that I thought was interesting about NPM, which is worth mentioning, is that you can just require a package, and that package is just a set of conflicts of other packages that have known vulnerabilities. So if you just include this package, whenever you do an update, that package would conflict with other known vulnerabilities, and you would get an error. So actually, I thought that was an innovative way, and that also exists for PHP also. Now we are in the house of Ruby here. Does anybody actually work at Shopify here, or we just use space? So what's Gems like?
So I'm not sure how many of the things on this list would be checked, but probably more like Pypi.
You think so? Okay. I glanced at it. I don't even know how to spell Ruby, so I didn't go there. But the sort of public perception I had was more like NPM than like Pypi. I would say in this, the thing that I discovered is I have a different view on how I trust third-party repositories, and also specifically on Pypi and Python itself, and then Python use. Dockerhub is worth a mention here. So Dockerhub doesn't, I couldn't really find a security governance statement. Okay, so the Docker, it's sort of in a different class. There are several things that concern me about Docker. One is that the container images typically run as root for perhaps sometimes valid, but other times unreasonable reasons. And so it immediately gives you opportunities for escalation of privilege. That was concerning. Also, because it adds yet another layer, right? If I do a Docker run Ubuntu, it is pulling down something from Dockerhub, and the parts that are in that container image came from a distribution, and the things that came from that Linux distribution would have come from some other open source vendor and maybe a repository. So it's just added yet another layer in there, another layer of uncertainty and an exposed attack surface. Not a clear incident response process. Just like other ones, you don't actually have to sign your packages, your container images. Nobody bats anything. It's a great place to host malware if you'd like. No integrity checking. You can download an image and then not know if it's really the thing that you asked for. No free monitoring, but there are commercial monitoring tools for all these. And so one of them is actually a WASP's dependency check tool, and it will do some of those. Unfortunately, I couldn't get it to run for me on Python modules. So, are you worried? But you're worried enough to come here and listen to me talk. Okay, so some recommendations. Oh, and the pizza? You wouldn't be here now anymore. The pizza's gone.
Oh.
All right, so here are my recommendations to you.
2 pieces left.
Make that 1. Recognize the supply chain as an attack surface and a place that attackers could hack your systems. And it's a place that people will often not look because they're mostly concerned about the code that they write. So inform your management. Be careful about what tools you actually, what upstream repositories that you actually use. There isn't that you need to say yes or no, but you should at least be aware of it. I'm guessing there's a lot of Python developers in the world who don't know that they don't even know what packages they are using, and they probably have never done any checks on it. Like all the people who are using Pycrypto. You should really use a free or a commercial scanning tool as part of your CI/CD pipeline. Right? Kathy did a great job explaining that. I'm not sure if there's a preference for free or commercial, but free or commercial is better than none, and frankly, the world is generally operating on none today. And also respond to vulnerabilities. So it doesn't just scan things, but actually do something with the results of the scan, right? A great way to get rid of all errors is to close standard error, right? Just never see an error again. Don't do that. It does not help. There's no point in running your scanning tool. A place that I will not mention regularly runs covariety on a large amount of source code, and just the results got mailed to a mailbox that they never saw. It's not my importer, by the way. And that's me. That's the code. If you really want to run it, the only person who's ever run it is me. But the presentation is on there too. So if you want to access the slides,